Hello, this is Ray, and we're going to be talking about quartiles from section 2.3. So quartiles are a way to divide your data, if put in order, into 4 groups that are roughly equal size. It's not going to be perfect depending on how many pieces of data you have, and so just a rough estimate of being able to group your data into 4 parts. And we have 5 numbers to kind of split up the data. And we have the minimum, and sometimes that's seen as a 0th quartile, but we don't usually use that, so I bold-face this minimum as the word that we normally use, and that's the smallest number in a data set. The first quartile is the number that splits the data into the first 25% and then the upper 75%. The median is going to be the number that separates half of the data. And then the third quartile is going to be at the 75th percent mark. So 75% of your data is below this number and 25% of the data is above that number. And then you have the maximum. That's the largest number in the data set. Now, it is important to put your data in order first to be able to do this. So we are looking at types of data that can be ordered. So quantitative data would be it. Once you have these 5 numbers, we can visualize this 5-number summary with a box plot, sometimes called a box and whisker plot. And the box plot is created by drawing lines that represent the first and third quartiles, and you have to be kind of like above a number line to be able to do this. And then you connect the tops and the bottoms of those lines to make a box, so that is where the word or name box plot comes from. Then you can draw the line in the middle for the median, and this could be, sometimes you see it as a dotted line, the median. And then sometimes the median and the first or third quartile are the same, so sometimes you don't see the median because it's just like one of the other boxes, one of the other sides. And then from the first and third quartiles, you draw your lines outward towards the maximum and minimum, and that is where the word whisker comes from. Now, when you draw this box, the middle of the box actually is a representative of something important for us, and that is the interquartile range. So the interquartile range, or IQR, is simply the difference between the first quartile and the third quartile. So you do this computation, Q3 minus Q1, to get your IQR. And Q1 and Q3 mark the 25 and 75%. So the 50% of the data that is in the middle is actually lying between Q1 and Q3. And that difference between them is the range. And so that becomes an important aspect for us, and it is useful for us for calculating things like or finding things that might be outside of the usual bunching of the data. So we have these things called outliers, where if you have a number that's way far away from the rest of the data set, and we call them outliers. So a systematic way of computing that is to figure out what 1.5 times IQR is. So it's 1.5 of that box size that you have in your box plot. And then you go to the left side, which is to say, left side of the box, which is to say you take your Q1 and you subtract this 1.5 IQR, and you'll see outliers that are small numbers, smaller than the data set. Or you can take the right side of your box, which is Q3, and you add the 1.5 IQR to that, and then anything beyond that would be an outlier that is really large. So those are ways to be able to use the 5-number summary. Let's do a quick example. Here we have 11 points, 11 salaries. They want us to calculate the IQR, determine if there are any outliers. So it'd be good to go through the process of finding the 5-number summary, maybe even doing a box plot, so we can kind of see what's going on. It looks like the numbers are not in order, unfortunately, so we're going to try to write them in order. And by doing a quick scan, you can find the smallest number, so that's 28. And what I'll do is I'll cross out the 28,000, and that would be my minimum, and then that's out of the picture. So the next number past the 28 is a 33. So put a 33 here, 33,000, and cross that out. Next number is in the 40s. There's a 40 here. That's 40,500. And then from there, the next number up is 42. So we have a 42,000. And then let's start again. 54 is next, I believe. There's 2 of them. So we'll write that twice. 54,000, 54,000. So we do have to account for each and every single data point. And then now we're in the 60s, 64. So 64,500 is the first number in the 60s. And then 68,500, 69,000. And then we have 72,000. And then we have the last one, 120,000. And just to double check, we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, as they said. All right. Now we do have the minimum and maximum. That's pretty straightforward. We have the min here, and then the max here. And then to find the median, we'll find the middle of the data. Since there are 11 numbers, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and then this number is right at the middle. So if you have an odd number of numbers, and that's going to be your n, then the number that sits right in the middle is going to be your median. If you have an even number of numbers, then you have to take the 2 numbers that are in the middle and find the average between them, and that would be your median number. Now from here, there's actually a couple ways to do the Q1 and Q3, which is what we need to do. One way is to include the median number and then do it that way and find the middle of those. The other way is to just take these things and then find the middle of those. Now the textbook, I think, did some examples where it's kind of easy to do it, but they say 1/4 of the entire set or less than that. So the middle of the upper half value, if we include the 54,000, then we have 1, 2, 3, 4, 5, 6. There's 6 numbers total, and to find the middle of 6 numbers would be the first 3, and then the second 3 would be right here. So to find your quartile, your first quartile, it would be the average between these 2 numbers. So this is 40,500 plus 42,000. Divide that by 2. So I'll punch this in the calculator and tell you in a second. Just a little calculator tip, especially when you're adding things and then dividing. There's this thing called the order of operations that's important. So we want to make sure that we add the numerator first, and then so that's 40,500 plus 42,000. And then before I press divide, I'm going to hit equals to, and so that is those 2 numbers being added. And now I'll divide this by 2, and I get 41,250. So 41,250 will be your median, or I'm sorry, it would be your Q1, which is the middle of these numbers. And now again, including the median for the upper half, there should be 6 numbers here as well. And so the middle number here, the median of the top half is the quartile 3, the third quartile. And these are 2 different numbers, so it's 68.5 plus 69 divided by 2. So again, with a calculator, 68.5 plus 69, and hit equals 2 first, and then we'll divide that by 2, and then we'll get 68.75. So Q3 is equal to 68.750. Okay, now we have our minimum, our maximum, our median, our Q1, and our Q3. Now let's figure out, well, let's draw it before we get to before we get to the IQR. Let's draw this so we can visualize what's happening. The thing to do is to draw a number line, and ideally you draw this kind of spaced out evenly. So this starts with 28,000, so maybe I'll start with 20,000, 30,000, 40,000, 50, 60, and I'm trying to do this as evenly as possible. 70, 80,000, 90, 100K, 110K, and the last one's 120, so I'll stop here. And then I'll just do some approximating. So let's work on the box first. You can do this in any order. I usually put the max and the min and then the median, and then I draw the Q1 and Q3. But let's do the Q1 and Q3 first. So this is 41,250. So that is pretty close to 40K. So I'm going to draw this first box over here to be your Q1. And then your Q2 is 68,007. So 65, 68 would be somewhere over here. And then sometimes it's actually good to label these things. So this is your Q1, which is 41,250. This is your Q2 or Q3, which is 68,750. And then from there you can draw your box. So this is the box part of the box plot. Let's find the median. The median is 54,000, so about halfway between 50 and 6K, a little bit less than half. And this, you can draw a straight line or a dotted line to represent the median. So median is going to be 540. And then you get the minimum. So 28,000 is close to 30K. You can draw the line and stop here. Sometimes we want to draw a little stopper over here so it doesn't just look like a straight line. And then 120K is all the way at the end over here, so we'll draw that line there. Okay. So this is our box plot. Now, what is our IQR? So our IQR is going to be pretty much the length between the Q1 and the Q3. So it's basically this space over here. And what we want to do is imagine if we take that space and we multiply it by another half or 1.5, is there anything that goes beyond that? If we do it to the left, you'll see everything here is going to be covered. But if you do it to the right, it looks like that last number here, the 120,000, is way out of reach from imagining, picturing about 1.5 times of that box. So this is just a rough idea of what the IQR can do for us. So I'm going to take this away and we'll actually do our analysis by making the computations. So our IQR is going to be Q3 minus Q1, and that is the 68,750 minus 41,250, and I think this is going to start off with a 500, and then I just subtract. There's a 7 and there's a 2, so 2750. So that's your IQR. So that means this distance from here, from Q1 to Q3, is a length distance of 27,500. And that's that length. Now imagine multiplying this by 1.5, so the boundary outlier boundary. There's two of them. We can start here at Q1, and then let's subtract 1.5 times the IQR, and then we'll get a result. Okay, so I'll do that in the calculator. Q1 was 41,250, and then I'm going to subtract out the IQR times 1.5, so that's 1.5 times I don't think this calculator did things the way it's supposed to, because I think I multiplied that by 1.5. So I will see if I can change calculators. Okay, so I think I can do the scientific calculator here. And then I have the parentheses ready. But order of operations means you do the multiplication first. And so this should be able to handle that without any parentheses. So I'm looking at Q1, that's 41,250, right? And then I want to subtract, minus, and then this is where the multiplication happens, 1.5 times the IQR, and the IQR was 27,500. So that's 27500. I get 0. So what this is saying, at least with this graph, is that this thing that I was pretending to stretch out, if I were to take that and put it at the end and then stretch it out by like 1.5, I'll eventually get to 0. So getting the 0 here. And clearly the last number I have for my data set is the minimum, which is 28,000, and it's not beyond 0. So there's nothing over there. So there are no outliers in the bottom. No outliers on the left. On the left side. So let's check the other one. We have Q3. This time we're taking that box that we kind of were playing around with and move it over here. And just visually it looks like there's the 120K that's sitting out there, but let's actually compute it. So this time we add 1.5 because we're starting from Q3 and we're going to the right. We'll add 1.5 times IQR. And what is that going to be? So our calculator again, Q3 was 68,750. So that's 68,750. And then we want to add the 1.5 times the IQR, and IQR was 27,500. So 27500, and then we get 110,000. So 110K. So it looks like I almost made it here. To make this a little bit more accurate, this got stretched out over here. So anything beyond that is an outlier. So outliers out here. And there is only one number that is, when we put it in order, there's only one number that's bigger than 110K, and that's 120,000. So the money amount of 120 is an outlier. Okay, so there you have it. A little bit about quartiles, the 5-number summary, the box plot, the IQR, and finding outliers. Okay, I hope that helps. Good luck.